In an early federal geological report, a few sentences about northern Arizona describe a very different kind of copper story from the one suggested by sensational headlines. The report does not describe a vanished industrial civilization. It does not describe underground cities, hidden railways, or a secret that explains all of America's ancient mines. It describes green mineral stains in sandstone, shallow pits, difficult roads, and a landscape that Diné people already knew long before a government geologist put it into English on a printed page. The place was White Mesa, on what the records call the Navajo Reservation in northern Arizona. Today it is Navajo Nation land. In the pale sandstone, copper occurs as green and blue-green minerals, especially chrysocolla and malachite. From a distance, the mesa can seem nearly empty. Dry ground, low rises, weathered cliffs, and a sky large enough to make every track look temporary. But at close range, the colour changes. A small patch of green in a rock can signal a mineral process that began long before any survey party, trading post, claim line, or company ledger. That physical detail is where this investigation begins, not with a legend, but with a specimen. What does the public record actually show about copper on Navajo land? What did early reports record about Diné knowledge of these deposits, and where does the evidence stop? The title of this episode begins with a claim, America's Ancient Copper Mines, What the Navajo Recorded. It is an attractive phrase because it promises a buried national story, yet the documents lead somewhere more precise. They show that the White Mesa deposits were known in the region, that an early federal report linked small pits in nearby canyons to Navajo searches for turquoise and green minerals, that commercial copper prospecting later brought claims, open cuts, hauls, and intermittent production, and that the Navajo Nation now has to manage the physical legacy of abandoned mines. Those are substantial facts. They do not need to be stretched into a conspiracy. The earliest record we'll use is a federal geological publication from 1906, a document written in the language and assumptions of its time. It called Diné people Navajos, and it used the outside gaze of a surveyor. The report said copper deposits on the Caibito Plateau and along tributaries of the San Juan had long been known to Navajo people. It added that green-tone mineral specimens shown to the geologists had led them to examine copper and Nokai canyons, where they observed numerous small pits. That passage is important, but it must be handled carefully. It is evidence of what a government report recorded. It is not a complete Diné account of who made every pit when the work happened, what materials were collected, how they were used, or which knowledge should remain private. It does not give us permission to transform mineral knowledge into a public spectacle, and it certainly does not establish an ancient continent-wide mining system. Still, the report changes the usual starting point. The copper story did not begin when a company arrived with claims and machinery. The landscape had already been read through colour, stone, and use. Green minerals mattered because green could connect to turquoise and to materials valued in regional exchange and artistic practice. The record does not reveal all of those relationships. It does show that an outside survey encountered local mineral knowledge instead of discovering a blank landscape. There is a useful distinction here. To say that people knew a mineral-bearing landscape is not the same as saying they operated a large commercial mine. Knowledge can mean noticing an outcrop, collecting a material, following a colour, testing a shallow exposure, or understanding where certain stones occur. Commercial mining means something else. Legally recorded claims, capital, transport, labour systems, processing, markets, and production ledgers. White Mesa contains evidence of both an earlier relationship to mineral exposures and a later documented commercial extraction history. They should not be collapsed into one story. The geology itself helps explain why. White Mesa copper was not a giant seam glowing through the earth. USGS descriptions place the minerals within sandstone, often in pore spaces, along fractures, and in irregular patches. The sandstone had formed as ancient wind-blown sand. Much later, water moving through rock left colourful secondary copper minerals behind. Malachite can appear green. Chrysocolla can range through green and blue-green. Their colours are vivid enough to attract attention, but colour alone does not guarantee a deposit that can be mined profitably. That difference would shape every chapter that followed. A rock can look rich in the hand and still be too scattered, too low-grade, too remote, or too expensive to turn into a durable commercial operation. The records from White Mesa repeatedly returned to this problem. Prospectors saw colour, engineers calculated distance, companies attempted to make the numbers work. The landscape resisted easy extraction. Before we follow those attempts, hold on to the first object. Pale sandstone marked with green. It is not proof of a lost empire. It is better evidence than that. It is a physical link between geology, local knowledge, federal documentation, commercial ambition, and the modern responsibility to repair what mining left behind. The next record takes us from a small mineral stain to a map of claims. It shows how quickly a place understood through material and landscape could be turned into coordinates, property lines, and promises of copper. By the time early 20th century geological reports described White Mesa in detail, the area had acquired another layer of meaning, the language of claims. A 1913 USGS bulletin traced commercial prospecting in the district to 1882, when Thomas V. Keams and companions examined the region south of Navajo Canyon and located dozens of claims. The report described prospect holes, shallow trenches, and open cuts scattered around promising surface exposures. This was not an ancient mining complex emerging from the ground. It was a late 19th century rush to turn visible mineral colour into a business. The distinction matters because claim records create a misleading sense of certainty. On paper, a claim can make a place appear already understood. Lines are drawn, names are assigned, tonnage is estimated, a camp may gain a trading post name. But White Mesa was difficult country, and the documents reveal the gap between owning a claim and operating a successful mine. The district lay far from the railroad, water was scarce, roads were rough, ore occurred irregularly. The same USGS descriptions that noted attractive green copper minerals also described the problems. Deposits scattered through sandstone, uneven grades, low average values, and the costs of hauling material across a dry plateau. A vivid rock in a prospect pit is one thing. Moving many tons of it to a mill or smelter is another. Imagine the chain of work required before a single pound of copper could become a saleable product. Someone had to find an exposure. Someone had to open a cut or trench. Workers had to separate mineralized rock from surrounding sandstone, or had to be loaded onto wagons or later trucks. It had to travel over roads shaped by weather and distance. It required water, supplies, labour, and a buyer willing to pay more than the transport and processing cost. At every step, the green colour in the rock became less romantic and more practical. That is why White Mesa is a powerful documentary subject. The story is not merely that copper existed. Copper occurs in many places. The story is how a small, irregular geological occurrence became a series of industrial hopes on Navajo land, and how those hopes left traces that later generations had to confront. The early reports used the name White Mesa District, and later documents also refer to the copper mine trading post area. Names in mining records often follow commerce: a district, a company, a road, a post, a claim. They tell us what outsiders needed in order to organize extraction. They do not replace the older relationships DNA communities had with the land. A responsible reading keeps both facts visible. The federal reports are useful sources for geology and business history, but they are not neutral or complete maps of DNA life. The 1906 account is especially revealing on this point. It said green mineral specimens exhibited by Navajo people had directed attention to copper and Nokai canyons. The author then interpreted the small pits through the framework of mineral search and turquoise. What we can say with confidence is narrow. A geologist recorded that Diné people knew these green mineral landscapes and that shallow excavations were visible. What we cannot say is equally important. The document does not supply an oral history transcript, a detailed chronology, or a community-approved explanation of every exposure. This is not a failure of the record. It is a lesson in how to read it. Historical documents often preserve a fragment at the edge of a larger knowledge system. The fragment can be valuable without becoming the whole story. If we make it into a total explanation, we repeat the old habit of taking an outside description as final authority. There is another problem with the phrase ancient copper mines. Archaeology and geology can tell us that people used mineral materials across North America for thousands of years, but that broad fact does not prove that every colourful outcrop was part of one coordinated system, and it does not make every later commercial mine ancient. White Mesa's documented corporate and claim history belongs largely to the late 19th and 20th centuries. The geological process is ancient. The commercial operation is modern. The human relationships to stone are more varied than either label can contain. At White Mesa, the mineral-bearing rock sits within what geologists called Navajo sandstone. That geological name refers to a formation, not to ownership by the Navajo Nation, and not to a simple story about people. The sandstone was laid down in an ancient desert long before human communities lived on the plateau. In some places, later fluids deposited copper minerals in pores, fractures, and thin zones. The result is not a single underground vault. It is a dispersed pattern that has to be found, tested, and measured again and again. This scattered pattern explains the shape of the early workings. Instead of one enormous shaft, the record described many shallow openings around the best exposures. The landscape itself shaped the technology. When ore is near the surface but irregular, prospectors follow stains, seams, and fractures. They dig where the colour seems strongest. They stop where the material fades. On a map, those marks can look like evidence of a grand hidden system. On the ground, they often tell a simpler story, repeated attempts to find enough ore to justify the next step. The next step arrived in the form of companies, leases, and a market for copper. The documents from 1917 onward do not tell a story of effortless expansion. They tell a story of intermittent work, high costs and operations that opened, stopped, and began again. That cycle is the key to understanding what the mines actually were and why their legacy is not confined to the past. In 1917, trade reporting described the White Mesa mine as being worked by the Navajo Copper Company. The notice focused on grades, distance, and expense. It said the deposit was in northern Arizona, far from the nearest railroad station, with available water many miles away. That short notice captures the basic tension of White Mesa. The ore could be valuable in a specimen, but a mine has to survive the geography between an outcrop and a market. The name Navajo Copper Company can easily cause confusion. It does not mean the company's name is evidence that the mine represented Navajo control, Navajo authorship of the records, or a unified Diné mining program. Corporate names often borrow the names of regions and peoples. The historical question is not what a company called itself. It is who held legal power, who worked, who carried the cost, who received the benefits, and what the records actually document. The best public sources show an intermittent commercial district. USGS work from the early 1940s described patented and unpatented claims, leases, an abandoned mill site lease, and renewed efforts to determine whether low-grade reserves could be developed on a larger scale. The report's conclusion was cautious. It advised that any further attempt should begin with careful analysis of mining and concentrating costs. That language is not dramatic, but it is revealing. The central mystery was not hidden treasure. It was whether scattered sandstone copper could be made economically viable. Engineers had to ask basic questions. How many tons of material could be counted with confidence? How much copper did it contain on average, not only in the best sample? Could it be concentrated? Could it be leached? Where would acid, water, fuel, and equipment come from? How far would a load travel? What would happen if copper prices fell? A district can contain copper and still fail every one of those tests. For White Mesa, the mineralogy created both possibility and difficulty. Chrysocolla and malachite are secondary copper minerals, formed close to the surface through weathering and groundwater processes. Their colours can be striking. They may appear as coatings, fillings, grains, or irregular concentrations in sandstone. But dispersed minerals are not automatically easy ore. A processing method must separate or dissolve enough copper from a large amount of a rock. That takes infrastructure, chemicals, water, and capital. The reports describe experiments and proposals rather than a stable, long-lived industrial complex. This is one reason the visual language of ancient copper mines is so misleading. It encourages a picture of deep tunnels and enormous chambers. White Mesa's historical record points more often to open cuts, shallow pits, prospect holes, small workings, and repeated testing. The physical evidence reflects a deposit that was visible near the surface but difficult to turn into sustained production. There were periods of activity. The district saw work associated with different companies across the 20th century, yet each new attempt had to solve the same old equation: grade, tonnage, transport, water, processing, price. It is tempting to treat the reopening of a mine as proof that someone had finally uncovered the secret. More often it means that a different company believed technology, financing, or market conditions might produce a different result. This brings us back to the people whose land surrounded and included these operations. Mining histories often reduce communities to a backdrop, a reservation name in the location line, a place name on a claim, workers in an old photograph. That is too thin. Navajo Nation land is not an empty mineral province. It is a homeland with political authority, families, grazing, roads, water concerns, cultural relationships to place, and its own institutions. Any account of copper that begins and ends with corporate claims misses the main condition under which the mines existed. The 20th century record also carries a larger lesson about extraction. A mining company can leave long before the consequences of its workings are finished. An open pit remains, waste rock remains, a road changes drainage, a shaft or adit can become dangerous. Equipment disappears, but disturbed ground and contaminated material can remain for decades. The original promise may have been copper. The later work can become safety, reclamation, monitoring, and repair. That is not an abstract possibility on Navajo land, the Navajo Nation's abandoned mine lands and uranium mill. Tailings Remedial Action Department reports a survey carried out in 1989 across Navajo Nation trust lands. The department says it mapped and inventoried coal sites, copper sites, and more than 1,000 non-coal uranium sites. Its published figure for copper is 33 abandoned mine sites, all reported as reclaimed. That number does not mean there were only 33 moments in the history of copper. It is a modern inventory figure with a specific administrative purpose, but it changes the story's scale. The question is no longer only whether a green mineral stain could become ore, it is also what happens after the market leaves. Before we turn to that legacy, there is one more source limit to face. The early records give us fragments about Navajo mineral knowledge, but the later commercial files are much fuller about companies than about Diné lives. That imbalance is not evidence that Diné people were absent. It is evidence of which kinds of activity government and corporate systems chose to preserve. The next part follows the documents beyond production and into that imbalance. What was recorded, what was not, and why a mine's most important history may begin after its last load of ore. Records are not mirrors, they are tools made for particular purposes, and they preserve some kinds of activity more clearly than others. A geological bulletin is designed to describe rock, ore, location, and economic potential. A corporate notice is designed to interest investors or buyers. A reclamation inventory is designed to identify hazards and organize cleanup. None of those documents was created to give a full account of Diné experience, family life, land use, or cultural responsibility around White Mesa. That is why the title's final words, what the Navajo recorded, need to be corrected. The public materials available for this episode are largely records about Navajo land, and records in which Navajo people appear through the limited lens of federal geology, commercial extraction, and later Navajo Nation environmental management. They are not a single Navajo archive speaking for all knowledge of copper. The responsible question is narrower and stronger. What do these records allow us to establish? They establish that green copper minerals were known in the region. They establish that an early federal report connected small pits in copper and Nokai canyons to a Navajo search for turquoise and green materials. They establish a later history of claims, prospecting, and intermittent commercial development at White Mesa. They established that mining on Navajo Nation land created abandoned sites requiring reclamation, and they established that today's Navajo Nation has institutions responsible for addressing that legacy. They do not establish a secret tradition hidden from the public. They do not establish that every shallow pit belongs to a single date or a single purpose. They do not establish that local mineral knowledge can be separated from the people and places that gave it meaning. They do not establish that an early geologist had access to all the knowledge held by Diné communities, and they do not establish a continent-wide ancient copper industry. That boundary is not a disappointment. It is the point at which a documentary stops treating uncertainty as an invitation to invent. Consider the material itself. A federal geologist could take a sample of green-stained sandstone, identify chrysocolla or malachite, estimate a copper percentage, and mark an exposure on a map. Those actions produce useful knowledge, but a mineral sample does not carry every relationship people have to a place. It cannot tell us who taught a child which colours to notice. It cannot tell us which paths were used in which season. It cannot tell us what should be photographed, collected, discussed, or left alone. A laboratory answer is real, but it is partial. The same is true of a mine feature. A shallow pit may be evidence of excavation. It is not automatically an archaeological invitation or a cinematic portal. Entering old mine openings is dangerous. Unstable ground, hidden shafts, bad air, and falling material can turn a curiosity into an emergency. More importantly, a feature on Navajo Nation land is part of a governed landscape. A viewer does not gain a right to search it because a century-old report mentioned it. This is where the modern Navajo Nation record becomes essential. The Abandoned Minelands program describes its work across a vast area of Navajo Nation trust land. Its public account says that, in 1989, the department surveyed sites and mapped 33 abandoned copper mines. It also reports that those copper sites were reclaimed. The work includes more than changing a map symbol. Reclamation can involve closing openings, reshaping disturbed ground, addressing hazards, stabilizing land, and restoring conditions where possible. The exact methods and conditions differ from site to site, and the public summary does not turn every mine into a case study. But the principle is clear. Mining is not just an event located in the past, it creates a duty in the present. When a company's calculation fails, the land remains. When a price drops, the road remains. When a claim expires, an opening can remain. Someone must decide what happens next. That is a more meaningful tension than a hidden mine story. At White Mesa, the same landscape can contain ancient sandstone, historic mineral knowledge, 20th century commercial work, and contemporary land management. Each layer operates on a different timescale. Sandstone formed in deep geological time. People identified materials in human time. Claims were recorded in legal time. Reclamation is carried out in administrative and community time. A documentary has to resist the temptation to flatten them. The phrase ancient copper can be saved if we use it only for the geology. The copper-bearing processes are old. The rock is old. The broader human history of mineral use in North America is old and diverse. But the White Mesa commercial district documented in these reports belongs to a much more recent era, shaped by rail distance, claims law, industrial demand, and changing markets. Calling that entire record ancient obscures what actually happened. The next question is practical. If the public record has limits, how can a viewer approach a story like this with curiosity rather than extraction? The answer lies in learning to distinguish an evidence trail from a treasure map. Return to the first image. Pale sandstone with a stain of green. For more than a century, people writing reports about White Mesa have tried to decide what that colour meant. To a geologist, it could indicate malachite, chrysocolla, and a process of mineral deposition in sandstone. To a prospector, it could mean a claim worth staking. To an engineer, it could mean a grade to test against hauling and processing costs. To a company, it could mean a possible shipment. To a reclamation crew, an old working can mean a safety problem that still needs attention. And to Diné communities, the land is never reduced to the value of a mineral sample. That is the answer to the question behind this episode. The public record does not show that the Navajo recorded a hidden national network of ancient copper mines. It shows something more specific. Early federal geologists recorded that Navajo people knew the green mineral landscape around Copper and Nokai canyons, and that shallow pits were visible there. Later records document a modern White Mesa mining district. Claims, prospecting, intermittent operations, and repeated economic difficulty. Modern Navajo Nation materials document the continuing responsibility to reclaim abandoned copper sites on trust land. Those facts should change the title we use. Instead of America's ancient copper mines, the evidence supports this. Copper on Navajo land has a layered history. Its geology is ancient. Its commercial mine record is modern. Its relationship to Diné land cannot be measured by a company's production figure. Its present-day significance includes safety, restoration, sovereignty, and the right to define what access and information are appropriate. That answer has a limit. We do not know from the public geological reports every purpose of every small pit described near Copper and Nokai canyons. We do not know the full range of Diné mineral knowledge because an outside survey was never designed to preserve it. We should not fill those gaps with invented dialogue, sacred explanation, or claims that silence proves a secret. A missing record can be a consequence of history, not a blank check for fiction. The strongest ordinary explanation remains the best one. White Mesa contains real copper-bearing sandstone. Its green minerals were noticeable. The deposits attracted commercial interest because visible colour could suggest ore. But the deposits were dispersed, remote, water-limited and expensive to work. Multiple efforts tested whether the district could become profitable. Their uneven history is written in reports more often than in grand structures. What remained after extraction was not a lost civilization. It was land bearing the marks of attempts to make mineral colour into industry. This is why the Navajo Nation's reclamation record belongs at the climax of the story. It restores human scale. A mine is not only a source of copper, it is a set of openings, cuts, waste, roads, workers, contracts, risks, and obligations. When the commercial chapter ends, the landscape does not close the book by itself. Public institutions and communities have to decide what repair looks like. The Navajo Nation's documented work on abandoned mines makes a clear statement without using dramatic language. The legacy is real enough to map, assess, and reclaim. That is not a footnote. It is a form of historical knowledge. It says that the value of land is not exhausted when an ore body has been tested. There is also a lesson for anyone who encounters an old mining story online. Ask where the claim comes from. Is there a dated report? Does the source distinguish geological age from the age of mining? Does it identify whose land is involved? Does it separate public indigenous history from speculation? Does it tell you what happened after the operation closed? And does it admit what it cannot know? Those questions protect us from the most seductive version of the past, the version where every broken stone is a clue to a secret and every absence is evidence of a cover-up. They lead instead to a history that is harder, more specific and more respectful. White Mesa is not a blank desert waiting for an outsider's revelation. It is a place where ancient sandstone holds copper minerals, where Diné people had knowledge of a mineral landscape before federal surveys, where commercial operators pursued claims with uncertain results, and where Navajo Nation institutions carry forward the work of addressing abandoned mines. That continuity is not a mystery to be extracted. It is a record to be read with care. If this investigation changed the way you look at an old mine, subscribe to Navajo Echoes. In the comments, name one public document, landscape, or historical record you would like us to examine next. Not for a secret hidden beneath it, but for the real story the evidence can support.